In this chapter, the topic of chemical quantities will be discussed. We will explain why the mole is an important measurement in chemistry. We will also show how a molecular formula of a compound can be determined. Chemists use a mole for measuring the amount of a substance by number of representative particles. A representative particle refers to the kind of particles present in a substance, atoms, molecules or formula units. For all molecular compounds, the molecule is the representative particle. For ionic compounds, the representative particle is the formula unit. To define a mole, we first have to introduce Avogadro's number, the number of representative particles in 1 mole, which is equal to 6.02 times 10 to the 23rd power. A mole is defined as the amount of a substance that contains a number of representative particles equal to 6.02 times 10 to the 23rd power. Let's illustrate with an example how moles can be converted to number of atoms in a compound. Atomic mass is a relative value that is expressed in AMU, atomic mass units. Atomic masses of the elements in the period table are weighted average masses of the elements' isotopes. The molar mass is defined as the mass in grams of 1 mole of representative particles in a substance. By definition, 1 mole of carbon atoms, carbon-12 isotope, has a molar mass of 12.0 grams. The table below shows the first 6 elements of the periodic table. It can be noticed that the value of the molar mass of the elements is equal to its atomic mass value. To determine the mass of a mole of a compound, we have to sum the molar masses of the atoms that make up the compound. Let's illustrate this with an example. How can we calculate the molar mass of sulfur trioxide? Sulfur trioxide is composed of 1 sulfur atom and 3 oxygen atoms. The molar mass of sulfur is equal to 32.1 grams per mole. The molar mass of oxygen is equal to 16.0 grams per mole. To obtain the molar mass of sulfur trioxide, sum the molar mass of each atom that make up the compound, and we arrive at 80.1 grams per mole. In other words, 80.1 grams of sulfur trioxide contains a number of molecules equal to Avogadro's number. The molar mass of a substance is the mass in grams of 1 mole of that substance. If the number of moles of a substance is given, the mass of the substance can be calculated using the first equation. To obtain the number of moles of a substance, simply divide the mass of the substance in grams by the molar mass of the substance. Let's calculate the mass of aluminum oxide if it's given that we have 9.45 moles of this substance. First look up the molar mass of the aluminum and oxygen atoms. Then determine the molar mass of aluminum oxide. The mass of aluminum oxide in 9.45 moles is equal to the molar mass times the number of moles. The result is 964 grams. The volume of 1 mole of any gas can be predicted using Avogadro's hypothesis, which states that equal volumes of gases at the same temperature and pressure contain equal number of particles. At standard temperature and pressure, also called STP, the volume occupied by 1 mole of gas is equal to 22.4 liter. Standard temperature and pressure conditions are 0 degrees Celsius and 101.3 kilopascal. So, at STP conditions, 1 mole of helium gas, 1 mole of ammonia gas and 1 mole of oxygen gas contain the same number of particles and occupy the same volume of 22.4 liter. The equations below allow to calculate the gas volume at STP conditions if the number of moles are known, or to calculate the number of moles of a gas at STP conditions if the volume is known. Relative amounts of elements in a compound are expressed in percent composition. Let's use an example to illustrate the concept of percent composition. Potassium chromate is composed of 40.3% potassium, 26.8% chromium and 32.9% oxygen. Why is that? Use the periodic table to find the molar masses of potassium, chromium and oxygen, and calculate the molar mass of potassium chromate. You should find that the mass of 1 mole of potassium chromate is equal to 194.2 grams. Since there are 2 atoms of potassium in potassium chromate, the relative percent by mass of potassium is equal to 2 times 39.1 grams divided by 194.2 grams, which is equivalent to 40.3%. In the same way, the relative percent by mass of chromium and oxygen can be calculated. It should be noted that the percent by mass of each element in a given compound is always the same. The equations below are useful to determine the percent by mass of an element in a compound. In chemistry, an empirical formula represents the simplest whole number ratio of atoms present in a compound, essentially showing the relative proportions of each element within a molecule, rather than the exact number of atoms in a single molecule. So, sometimes the empirical formula will be different from the molecular formula. An empirical formula is a way of expressing the composition of a chemical compound. Compare methanol, ethanoic acid and glucose. They have the same empirical formula, CH2O, but different molecular formulas. An example will be used to illustrate how to determine the empirical formula of a compound, if the percent composition of the compound or the mass of each atom is known. Here is the procedure to find the empirical formula of a compound. Calculate the number of moles for each element in the compound. Identify the lowest number of moles among the elements. Divide the number of moles of each element by this lowest number of moles. This will give you the molar ratios for the different atoms. Exercise. A sample contains 25.9% by mass nitrogen and 74.1% by mass oxygen. What is the empirical formula? Since we are dealing with percent composition, let's assume that we have 100 grams of the compound. The molar mass of nitrogen is equal to 14.0 grams per mole and the molar mass of oxygen is 16.0 grams per mole. So, we have 1.85 moles of nitrogen and 4.63 moles of oxygen. The lowest number of moles is 1.85, so divide both number of moles by 1.85. So, for each mole of nitrogen, there is 2.5 moles of oxygen. Since these are not whole number, we have to multiply by 2 to find the mole ratio of nitrogen to oxygen equal to 2 to 5. So, the empirical formula of the compound is N2O5. In the next short video, we will show how the molecular formula can be determined.
Pretend we have 100 grams of the hydrocarbon, 92.4 grams would be carbon, and 7.6 grams would be hydrogen. Using their atomic masses to convert to moles, we get roughly 7.6 moles of each, which indicates a 1-to-1 ratio. Therefore, the empirical formula of benzene is CH. This means that there is the same number of carbon atoms as hydrogen atoms in the molecule. If we want to find the molecular formula, which is the actual number of atoms of each element in a molecule, we need the molecular mass. Let's say we know that for benzene the molecular mass is 78. 1 unit of the empirical formula weighs 13, and 78 divided by 13 is 6. This means we need 6 units of the empirical formula to get the molecular formula, or C6H6.